Yes, class. So yesterday, again, same thing. Mir, you didn't attend the ray optics class. Why aren't you attending ray optics? See, ray optics won't be discussed in this batch again. If you're thinking we'll complete it till EM waves, then we'll start with ray optics. See, ray optics is a difficult lesson. Still, I'm going very slow in that batch. We have just done one whole major reflection portion. So you should join the classes, otherwise you will miss on this very important lesson. Anyways, yesterday we had stopped at this point. See, this wasn't completed. So time frequency is 1 over time period. Time period was 2m, 2 pi m by qb. So frequency will become just reciprocal of it, qb by 2 pi m. qb by 2 pi m. Now omega is equal to v by r. Remember in circular motion, in class 11th you must have done this, or I have also revised this. V is equal to omega r. So omega will be v by r. What was v? Q b r by m, and this r. So r will be cancelled. So omega is equal to, or you can even get it from this formula, omega is equal to 2 pi nu. 2 pi will be cancelled. So qb by m, this will be left. Fine. Also, one more thing, one last thing. Kinetic energy. Kinetic energy's formula is half mv square. Kinetic energy's formula is half mv square, right? So once you substitute in the value, v square will be half mv square is q b r by m whole square. So it will be q square b square r square m by 2m, mm will be cancelled. So kinetic energy is q square b square r square divided by 2m. This is the formula of kinetic energy. Write it down and we'll see questions from this. Till here you people have already written yesterday. From here we have to start it today. C class, this question says that a proton, a deuteron, and an alpha particle enters in a uniform magnetic field perpendicularly. Calculate the ratio of the radii if they enter with these many things same. So these are different parts which you have to remember. See, mass of proton and charge. This you have to remember. So mass of proton is, let's say, mp. Charge is the electronic charge. Mass of deuteron is twice of mp. And charge on deuteron is electronic charge. Mass on alpha particle is 4 times. This you have to remember. This won't be given in the question. These things by solving question only you will be familiar with, because there is no table, there is no such chart which will help you or which I can share. We can just solve it through the help of questions. Usually proton, deuteron and alpha particle come. Most important is alpha particle, how and their relation with protons. Now you have this. So first part says same velocity. Also formula of radius is mv by qb. So first part says same velocity. So for same velocity, look, mass mv by qb is the formula. So mass of proton mp. Same velocity, I'm writing it as v. Charge of proton qp, and magnetic field will also be same for all the particles which are entering the same magnetic field. B is the same common magnetic field, right? Is 2. Now come to deuteron. Mass of deuteron into velocity. Mass of, not mass, sorry, charge of deuteron. Charge of deuteron into magnetic field. Then mass of alpha particle into velocity. Charge of alpha particle into magnetic field. See, velocity and magnetic field will be cancelled. Now, mass of proton is mp. Charge on proton is e. Mass of deuteron is twice of mp. Charge on deuteron is e. Mass of alpha particle is 4 times mp, and charge on alpha particle is 2e. Now see again, MP will be cancelled. E will be cancelled from here. And this is 2, 2 twice. So this is equal to 1 is 2, 2 is 2, 2. This is the ratio. This is how you have to solve for same velocity. Second part. Second part says same momentum. So mass into velocity is same. So mass into velocity. Now I'm not writing mass separately for proton, deuteron, alpha particle, because mass into velocity is same already. Charge of proton into magnetic field. Mass into velocity by charge of deuteron into magnetic field. Mass into velocity by charge of alpha particle into magnetic field. MV, MV, MV. And all the magnetic field will be cancelled. Now, what is this value? 1 by E. This is also 1 by E. This is 1 by 2E. So answer is 1 is to see 1 by E, 1 by E, 1 by E will be cancelled. So 1 is to half, or you can say 1 is to 0.5. This is the answer. Clear? This is how you have to solve. Whichever quantity is same, you have to bring your answer in terms of that. Like momentum, and momentum wasn't there. So mv, I derived it as momentum. So I use this. Coming to kinetic energy, the third one. Now see, kinetic energy is formula and radius formula. So I'll use kinetic energy. From kinetic energy's formula, I'll use the formula of radius. Understood? When I say Rp is to Rd is to R alpha, kinetic energy was Q square B square R square by 2m. This was the formula. So from here, R will be equal to what? Under root 2m kinetic energy by QB. From here, radius will be equal to under root 2m kinetic energy by QB. Why not under root QB? Because they are square. So when you will take their power half, square will cancel. Now in term of this place everything. Under root 2, mass of proton, kinetic energy same by charge of proton into magnetic field is 2 mke by qb. Mass of deuteron, charge on deuteron is 2. Mass of alpha, charge of alpha. Now see, root 2, root kinetic energy and B will be cancelled, right? So we are left with root 2 MP. So root MP is there. Okay. By charges E. Then root 2 MP, charge E. Root 4 MP by charge 2E. So again, root MP will be cancelled. EE will be cancelled. And root MP is cancelled. From here 1, from here root 2, from here, see, root 4 by 2. Root 4 by 2 means 2 by 2, which is equal to 1. So 1 is 2, root 2 is 2, 1. This is how you have to modify the answer to get the same kinetic energy, because that is the question. When it was asked about the same momentum, so we have to obtain same momentum. Last part, same potential. See how to get same potential. Now we haven't studied any formula. Kinetic energy we also studied. Radius already we did. Momentum, velocity, everything we did. But potential we haven't done here. So there is one relation which this will be discussed in your dual nature. This will be discussed in your dual nature. Kinetic energy is equal to charge into potential. So that radius formula which we were using, under root 2m kinetic energy, we can use qv by qb. Now come back to ratio of proton, deuteron, alpha particle. So this is 2 mass of proton, electronic charge, same potential. Electronic charge, same magnetic field is 2. 2 twice of mass of proton, electronic charge, potential, electronic charge, magnetic field. 2 4 times mass of proton, twice charge into V by twice charge into B. C. What will be left? Root 2, root 2, root 2 cancelled. MP, MP, MP cancelled. EV, EV, EV cancelled. EB, EB, EB cancelled. From here, what are we left with? Nothing. 1. From here, this root 2, right? Root 2. Rest of it were cancelled. Okay, this is... okay, this 2 and this 2 will be cancelled. So root 4. Okay, no. This is root 2. Sorry. They can't be cancelled. They can't be cancelled. See, we are left with root 4 into 2 by 2. So this is directly, let's write it as 8. Root 8 by 2. So root 8 can be written as 2 root 2 by 2. So we are left with root 2. This is the answer. This is how you have to solve these types of questions. A very good lengthy question I have taken so that every topic is revised here and you don't have to scroll other topics. This is a very important question. Mark this as important. And please, wherever you are not able to understand, let me know. This completes with the third case. Now only one last fourth case is left that we'll do. Yes, class. Can we start with the fourth case which is left? So first case was angle 0. Second case was angle 180 degree. 180 degree. Third case was angle 90 degree. Okay? So 0, 180, and then third case 90. So all the three cases you have. Now, fourth case is not even 0 degree, not even 180 degree, not even 90 degree. At a random angle. This charged particle is present over here. This charged particle, this is present at a random angle. This charged particle, this is present at a random angle. Let's say this is making some angle theta. Now, if this is moving with velocity with some angle theta, what will we do? The first step that comes is resolving the vectors. The parallel component to magnetic field will be V cos theta. The perpendicular component to magnetic field will be V sin theta, correct? Now what happens? Now what will be the motion? The question is, what will be the motion of the charged particle? See, this parallel component V cos theta, this moves charge in a straight line. This moves this in a straight line. And what does this V perpendicular do? V perpendicular makes it into a circle. So the body moves further, then a circle because of V perpendicular. V parallel makes it move in a circle, straight line. Then again V perpendicular makes it in a circle. So what is the ultimate result? Ultimate result is that V parallel, then V perpendicular. Again V parallel, V perpendicular. V parallel, V perpendicular. So this is the helical path. The path that we obtain in the fourth case is helical path. So V parallel moves charge in a straight line, V perpendicular moves charge in a circle, charge particle in a circle. So path will be helical. So here the magnetic the velocity component which will be used is V perpendicular. Because when you will be solving questions, you will just have one velocity, but here we are obtaining two velocities. So always use the perpendicular one because this is responsible for the circular motion. Fine, quickly write down this fourth case also. I want to start with simply Lorentz force, a very, very small topic. See class, now when we talk about Lorentz force, you have to understand that when we talked about electric force, in electric force, we said that the formula of force is QE. So this is the condition when electric field is present. Electric field is present, you're getting the force as QE. What if magnetic field is present? That also we have seen. If magnetic field is present, then formula of magnetic force is Q V cross B. Suppose it's the charge is in a region where electric field is also present, magnetic field is also present, then you will add both the forces to get the cumulative field, right? Because here the net force will be what? Net force will be electric force plus magnetic force. So net force is charge into electric field plus magnetic field is forces V charge into V cross B. So what is the net Lorentz force which we say? Lorentz forces, take Q common, E plus V cross B. This is the formula which you need to remember. And this is cross product. Regarding the directions, you already know about the directions. For electric field, positive charge will be in the same direction as that of electric field. Negative charge will be in opposite. Magnetic force, we have already used right hand thumb rule. Let's practice a question also. But first you write it down, then only you'll be able to answer the question. See class, this question will involve a concept of dot product because I've already told you V cross V is solved with dot product. So what is the Lorentz force? Lorentz force is Q E plus V cross B. Now see, first let us solve this V and B. What is V? I cap minus 2j cap, that's it. What is B? I cap minus j cap minus 5k cap, right? So how do we solve dot products? Determinant system we have discussed. So I cap, j cap, k cap. So this is 1 minus 2, 0 because k cap is not there. Coefficient of I cap again 1, j cap minus 1, k cap minus 5. So firstly, look here. For V cross B, first I cap, we'll eliminate this. Then going vertically downwards, vertically upwards. So this becomes minus 2 into minus 5 first, minus 0 into minus 1. This is I cap. Clear? Minus 2 into minus 5, minus 0 into minus 1. J cap, I have always told you, put a negative sign initially. Then go vertically down, vertically up. 1 into minus 5 minus then 1 into 0. J cap. J cap also done. So this is a revision from your class 11's topic. Last, eliminate this. You are left with these 4 going vertically down, vertically up. That means plus 1 into minus 1 minus 1 into minus 2. This much k cap. That's it. Now you just have to solve this equation. This will be minus 2 into minus 5. This is 10. 10 I cap. This is 0. This is minus 5. Then minus j cap. So minus 5 j cap means plus 5 j cap. 1 into minus 1, 1. 1 plus 2. This is minus 2. So 1. So 1 k cap. Correct. This is 1 into minus 2, minus 2. Minus 2, minus 2 plus 1. 2 minus 1, 1. That is k cap. This is just V cross B. Now what you have to do? You have to do E plus V cross B. This is simply V cross B that you have obtained. What is electric field? It's given 2 I cap minus 3 j cap. So 2 I cap minus 3 j cap plus 10 I cap plus 5 j cap plus k cap. This is equal to 12 I cap plus 2 j cap. Here this is 0, this is k, so plus k cap. Okay. Then this is E plus V. Now what we have to do? Finally, it's Q into E plus V cross B. So what is the charge? 2 coulomb of charge. So 2 into this entire term. What is this entire term? 12 I cap plus 2 j cap plus k cap. Final answer, net force. 24 I cap plus 4 j cap plus 2 k cap. That's it. This is how you have to solve all the questions. Tell me, this is clear? All of you?
Yes, ma'am.
Deborah, clear?
Yes, ma'am.
And what about you three? Amna, Rajita, Sidra, clear to all of you?
Yes, ma'am. Yes, ma'am.
Okay, very good. Then. Any doubts if you all have, please let me know. See, class, the next topic is force on current carrying conductor in magnetic field. So if only one conductor is present, we'll see one more case, that is force between two parallel conductors which are present in magnetic field. So if only one single conductor is present, which is carrying current I, then what is its formula? Formula is very easy to derive also. Derivation doesn't come. This formula is just helpful in other derivations and in between the numericals. But formula is very important. Like it's like Ohm's law. See, Ohm's law, V is equal to IR. Basic questions on Ohm's law you have never seen, right? V is equal, just calculation of V is equal to IR in a very good long question. No, but you have seen everywhere, be it the combination of circuits or any other thing, we have seen the application of Ohm's law. So this is also that type of question. So length of the conductor is L, area of the cross section is A, I is the direction of the current, I is basically current, and N is number of density. Number density means number of electrons per unit volume. Now if length is L, area of cross section is A, so volume will be AL. Now total number of electrons. So if number density is N, so an entire volume is AL. So number of electrons, total number of electrons will be NAL. Now force we have studied. Force is E, drift velocity into magnetic field. The type of velocity that we will be using is drift velocity. Right, the velocity with which the electrons drift within the conductor, move within the conductor, is drift velocity VD. So C, and yes, what is the total number of electron? NAL into E, VD into B. Class, can you recall this? NEAVD. NEAVD. Is it equal to something? Can anyone answer? NEAVD. One relation we had seen when we were discussing current electricity. NEAVD. No idea. Not drift velocity. Drift velocity is already here. This is equal to current. I gave you a question also. Relationship between drift velocity and current. This is a very important formula. You have to remember this. See, so magnetic field, this is basically I, L cross B, because L is left, I we have taken it out. This is important formula. I've told you its relevance. And when I say ILB, it means ILB sine theta you can use. So magnetic force acting on conducting wire. Like I'll give you an example. See, look at this example. Force is equal to BIL sine theta. Sine is 90 degree. You can see between length and magnetic field. Magnetic field is inwards. B 2. Current 5 amperes. Length 10. This becomes 100 Newton. Now coming to the direction. Direction, how will you write? Direction we have seen. Yesterday also we did these types of questions. Keep your right hand along the direction of current. Curl your fingers inwards because magnetic field is inwards. Thumb will give you direction. So thumb here is upwards, which is J cap. You can write J cap, you can write upwards. Both are valid. Fine. Look at this question. One more example. Same thing. 2 into 5 into 10, which is equal to 100 Newton. This is same, but direction. Class, answer the direction. All of you answer the direction in the chat column right now. Amna, Deborah, Rajita, Sidra. Keep your palm in the direction, along the direction of current. Curl your finger towards magnetic field, which is outside. Tell me where is the thumb pointing? Right, left, up, down, in, out, where? If you are Curling the fingers outwards. Palm should also face outwards. Thumb should point. Correct. Sidra has answered it correctly. So only Sidra knows. Rajita, your answer. Deborah, Amna. If your palm is facing you, you are curling the fingers outwards because magnetic field lines are outwards. Thumb should point where? Right hand. Use your right hand. See, right hand. Fingers will be like this. When you will curl the fingers, fingers will be curled like this. So thumb is pointing towards the right. Palm is facing towards you. Fingers got curled like this. So thumb is facing like this. That is right. I cap you can say, or you can say right. Note it down. All those who have written, you can leave. Next weekend, we'll continue this. So a small portion is left only. Your chapter will be over. This is, they both are very small. Conservation. This will be completed next week itself. Okay. Thank you so much, class. Please attempt your after class assessment.